Everybody, Samuel Singer here, the founder and executive director of Wyoming Stargazing. Thanks for joining me and welcome to Mind Bending Astronomy. In every episode, we'll share with you, a mind-bending fact about astronomy. Yesterday, we learned how Maxwell's equations and the Lorentz Transformations show that there was something fundamentally wrong with the way Galileo and Newton formulated their laws of motion. Basically, they had the speed of causality incorrect. Now that we know the speed of causality is not infinite, we have to take a look at what that means for universal agreement of any observation in the universe. I know this may seem like we're going around and around in circles, but trust me, what we're actually doing here is laying the foundation for understanding the true nature of the cosmos. To do that, we need to introduce another mathematical concept called the space-time interval. It turns out that the only thing that can be universally agreed upon by any two observers moving at different speeds anywhere in the universe is the space-time interval. Two observers moving at different speeds don't agree on the time between events, the distance between events, or the order in which events occur. That's why the space-time interval equation is so important. It tells us how events are causally linked. In other words, which events can influence other events. Now, this concept of space-time is not just a combination of the normal way we think about space and time. We have to totally abandon the idea of a universal flow of time and a universal grid of space that we're moving through. These ideas simply don't exist in that way. Matt O'Dowd and Gabe on the PBS series Spacetime, which I've been suggesting that you watch after my videos, do a fantastic job in describing this concept of the space-time interval, as well as everything else we're talking about. Seriously, these guys rock. In this case, Gabe says that reality is really a four-dimensional geometric existence in which everything, including you, can be represented as a series of geometric points. Connecting these causal points together forms a line. That line represents a series of events that we normally think of as happening through space and time. But we're not moving along that line. We are that line. You can watch Gabe's full talk by clicking on the link in the comments section below. Before I wrap things up today, I want to make sure you're beginning to see the connections between what we've covered so far. Here goes. Light is electromagnetic radiation that moves through space as a wave of interacting magnetic and electric fields. The energy of that radiation is transferred in finite massless particles that we call photons. Just like photons, other subatomic particles like electrons, and even whole individual atoms and even molecules can't be said to exist until we observe them or make a measurement of them. They only exist non-locally as probability before we make an observation or measurement. Because the speed of causality is finite, for everyone to agree on the measurements we make, we have to use special ways of keeping track of our frame of reference. That's what the Lorentz Transformations and the space-time interval equation allow us to do. Using them, we make universally agreed upon statements about which events cause other events, as well as when, how distant, and how strong those events actually were. On Monday, we're going to explore how our new understanding changes the way we think about mass, which eventually will lead us to a discussion of Einstein's theories of special and general relativity. Until then, be well, and don't forget to look up.